Following on from the previous video, we got to this stage here where we checked all four, and then it boils down to us trying to determine whether or not this thing will diverge or if this thing will converge. So it boils down to us trying to integrate this. So we would try and visualize this as 2 to the power minus x. So we got to this stage here. So we are trying to integrate this. But let me remind you something. You should already know the following. But let me just give you a quick reminder. When you differentiate this 2 to the power of, let's say, minus x, you would natural log both sides. So this thing will come down here. So that will then give you this. So from here, natural log both sides. That will then give you this. Use implicit differentiation. That will then give you this. And then blah blah dy by dx equals this whole thing here. So hang on, let me go back a few steps. We are trying to integrate this. So we are really looking for something in such a way that when we differentiate it, it will give us this thing here. But then if you look at this, if you differentiate this, it gives you this. Now we are trying to seek this. You see, when you differentiate this, it gives us something near enough what we're trying to seek. We are trying to seek this. So hang on, let's go back one step. So we are looking for something in such a way that when we differentiate it, it will give us this. But then if you look at this, 2 to the power minus x, 2 to the power minus x, you see, well, if you differentiate this, it will give you something near what you're trying to seek. You're trying to seek this. So this thing here, you don't want this constant here. Natural log of 2 is just a number, it's just a constant. So we don't want this thing here. So we would go back here and then make the adjustment. If we make this adjustment, stick a minus 1 in here. So if we make this adjustment, if you differentiate this now, it will then give you positive natural log of 2 and then times 2 to the power 2 to the power negative x. That's near enough, but we don't want this this constant here. So if we make this adjustment, if we make minus 1 over natural log of 2, now if you differentiate this whole thing here, it will then give you what you're trying to seek, 2 to the power minus x. So the point is that if you integrate this, it will give you this thing here. So think about it. Integrate this, and then it will give you this thing here. Use whichever method you want to integrate this, but there are other methods. You use whichever method you want. So integrate this, it will then give you this. So now if you put a very, very big number into here, this thing here will be massive times a constant. So that the whole denominator here will be massive. 1 divided by something that's really, really big is going to be 0. So this is going to be 0, and then 0, and then you've got to put this 0 into here. So putting 0 into here, this will be 1 times a constant. So it's going to be this. Okay, so evaluate this whole thing here, it will give you this. So what we now know is that this thing here is going to converge to this. So now going back to the theorem that says if this thing here diverge, this thing here will diverge. If this thing here converge, then this thing here converge. So we've just established that this thing here is going to converge. So therefore the series itself must also converge. So this series here will converge. Okay.